Hello, in today's lesson, we're going to be focusing on the last lesson of Module 1, Topic 1. So we've already gone through all the transformations. Now what we're left with is how to write whether two objects are congruent. So we're going to be going through a lot of different activities, 3 activities and 1 activity called Talk the Talk, and we're going to be skipping quite a bit. Right now we're going to be starting with page 71, ending at page 78, but skipping quite a bit. Okay. Anyways, so I'd like for you to start at page 71, labeled Activity 1, Congruent Statements. So if you look off to the right, we have these 2 triangles here, and they're called triangle ABC and triangle DEF. Okay. If you have a highlighter, you're more than welcome to take that out. We'll be highlighting / circling a bunch of different things. All right. Pretty much what happens is if you have 2 congruent objects, you can say a couple of things. You can say that they have congruent line segments, which are the boundaries of that shape, and they have congruent angles, and we'll talk about that later. How we write this, though. It says you can write a single congruent statement about the triangles that shows the congruence between the 2 figures. For the triangles, we can say triangle ABC is congruent, right? This symbol right here with the squiggle and equal sign means congruent. The squiggle means it's the same shape. The equal sign means it's the same size. We have this written in our intro to transformation notes, but I just wanted to revisit that. All right, in the worked example here, what we can say, and I'll be going up, about these 2 figures is if the length of the line segment AB is equal to the line segment DE, you can use the following symbols. So AB, I'd like for you to put a tick mark through that, and ED or DE, a tick mark through that. Generally, when you put a tick mark through a line segment, that means that they are equal shape, equal size. We'll talk about the other ones as well, but how we read certain things from here. So we use an equal sign. We have here AB, the distance of AB is equal to the distance of DE. And you can just read that here off in quotations. That's what that translates to. That's similar, not exactly the same as this next statement, where we have an M and then we have a line above AB. What this says, and you can read it off right over here, is the measure of line segment AB is equal to the measure of line segment DE. And then we're saying that if they have the same shape and size, you can say, finally, line segment AB is congruent to line segment DE. So it has a squiggle and has the 2 equal signs. We're going to, for the first problem, it says write congruent statements for the other 2 sets of corresponding sides of the triangle. So let's go ahead and look up here. And they're color-coded as well. We can see that BC, I'm going to put 2 tick marks here. That's in orange. That's congruent to the other one that is in orange, which is EF. So let's go and write that statement below for number 1. So that is line segment BC is congruent. Normally I put the squiggle and then I put the equal sign below it. It's congruent to line segment EF. And finally, of the 3 sides, the only one that we haven't gotten to yet is this one. I'll put 3 tick marks. And that is line segment AC and DF. And we say DF and not FD, because notice how this one I start with the red point and then green. So this is the red point and then green. So it is DF. You would go in that order. That is important. We'll talk about that later when we get to angles. But let's go and write that here. So last one, line segment AC congruent to line segment DF. Okay, let's go and flip over to the next page, which is talking about corresponding angles. So this is the sides of a figure, but also the angles, if they're congruent. If the figures are congruent, those angles are congruent as well. So we're on page 72. So corresponding angles here are angles that are equal in measure. So inside the worked example, we're comparing 2 of these angles here. And when we Note whether two angles are congruent. Instead of drawing tick marks, we draw an arc. And we'll do that for this first one. So we're saying this is read as the measure of angle A is equal to the measure of angle D. And then here it says when the angles of two different triangles are equal in measure, for example, the measure of angle A in the first triangle and the measure of angle D in the second triangle, then these angles are congruent. And we can express it like this. We say angle A is congruent to angle D. I will write that here. We'll put an arc like this and like this. So put that arc there, and you can see that it's already color-coded in red, right? A is in red and D is in red. So that helps us identify it, but we're not always going to have that. So we're just looking at which parts correspond in these two congruent figures. Let's go ahead and draw those angles for number 2. Write congruent statements for the other two sets of corresponding triangles. So we're going to say, I'm going to go to the next one in ABC, so B, angle B here. So that is, I'll draw 2 tick marks there. That is congruent to, which one do you think it is? That is angle E. All right, and then the last one, you can see that they're both in green. We'll put 3 tick marks. Oops. All right, that is angle C is congruent to angle F. All right, so what we have here is 2 triangles that are congruent. We're going to go to number 3 on the same page. And it says write 2 additional congruent statements for these triangles. I'm just going to do 1. Instead of 2, I'll put 1. We have this, right? Triangle ABC is congruent to triangle, and I'm going to line this on top of it, DEF. So what I want you to understand here is what we wrote, what was in the worked example is angle A is congruent to angle D. And that's nice here because we can see that they're lined up. If you don't have a highlighter, you can just circle these, right? Angle B is congruent to angle D. We see that right there. And the last one, I'll put in a different color. Let's see, yellow. C is congruent to angle F. So another one, I don't know, is we just jumble up A, B, and C. Instead of A, B, and C, let's go in a different order. Let's say triangle BCA. We're going to say triangle BCA is congruent to. Well, we'll have to keep that order. As you can see, B is congruent to E. So we started with B here. On this second triangle, I'm going to start with E. BCA, the second one is C. So C's right here. The one that corresponds with that is F. So triangle EF. And the last one, since it ends in A, the last one will be D. So we will put it in that order. The order is important because you're saying these varying parts correspond with each other. Okay, so that's activity 1. We're going to do part of activity 2, really just one part of it. So pretty much just page 73. So I'd like for you to flip over to the next page. Now there's a lot of problems with this one. We're going to skip 2 and 3 on the other pages. We're just going to do number 1 on activity 2, and then we'll move to activity 3. Okay. So the topic here is using rigid motions to verify congruence, meaning we already know the figures are congruent. We're going to prove why are they congruent, and then detail which parts are congruent as well. So it says analyze the 2 triangles, right? We have the 2 triangles here. We have the coordinates. We're not going to really focus too much on the coordinates for now, but let's look at A. Identify the transformation used to create triangle PMK, this one here. I'm going to circle it, but you don't have to circle it. And from this other triangle, so we're going from the unshaded to the shaded. Now, we're using any transformation. I know we just worked on rotation, and this actually turns out to be a rotation. So about the origin, if we're not sure of the rotation, this part I'm going to draw. You don't have to draw. I'm going to connect one of these. I'll connect C to the origin, and I think that corresponds with K. And as you can see here, that looks like a right angle. We're going this way. So this is telling me, okay, it's a rotation, and it's a 90-degree rotation counterclockwise. I'm going to erase that. So let's go and put that here. We're going to say triangle TWC rotates 90 degrees counterclockwise. CCW to create the other triangle, the shaded one. All right, let's create a triangle congruent statement. So we're going to have to write the following parts here. Let's go and write, since I already wrote TWC, let's put triangle TWC here. This is congruent to the other triangle, and let's be careful what we're highlighting here. Angle T, I'm going to put one arc here. Which one do you think corresponds with angle T if this is a rotation? This corresponds with P. They're about opening, that angle's opening about the same angle. We might confuse this with M, but that would be more of like a reflection, but that's not the case here. Anyways, so we'll put K. Oh, sorry, not K, P. Whoops. P. All right, so TWC. So for the second one, I'll put two arcs. Oh my goodness. Okay, hold on. This one right here. Which angle corresponds with W? That looks like it's going to be M right there. So this is triangle PM. And the last one, C, I'll put three arcs here. That's going to correspond with this other one, which we said earlier. That is K. So we can, the congruent statement here for the triangle. Triangle TWC is congruent to triangle PMK. Next one we're going to talk about is identify the congruent angles here. And that's pretty much just lining up the corresponding parts here. So the first parts with the second parts and also with the third parts. That's all we're doing for this one. Okay, so let's say triangle or angle T. What is that congruent to? That is congruent to the other one that's highlighted in yellow. That is angle P. All right, let's keep going. Angle W is congruent to angle M. And the last one, angle C is congruent to angle K. All right. And then let's go to this next part, which is congruent sides here. I'm going to look at the figure itself just because it might be kind of confusing to look at varying parts, but let's put tick marks here. Let's start with TW. I'll put one tick mark there. That corresponds with PM. And with this, we want to be careful there, not to confuse with MP, because you would be saying specific angles are congruent there, and they're not. So let's put triangle or angle, or sorry, not angle. Side length. So this is line segment TW is congruent to line segment PM. Right, TW, that's right here. PM, that's right here. You can see that they're the first and the second spot. All right, I'll get rid of those lines. Let's go next to angle line segment WC. That's the second and the third. That's congruent to the second and the third here, which is line segment MK. And then finally, the last one here, we'll say TC. So the first and the third, that's going to be congruent to. So line segment TC is congruent to line segment PK. All right, good. On the next page, page 74, it's exactly the same thing, just with a different transformation. This is a reflection. If you go to page 75, that is a rotation. It looks like also a translation. We're going to move on to activity 3, and we're going to do 3 problems on activity 3. Go to talk the talk and call it a day. All right, so on number 1, it says transformations with coordinates. We're not given a figure. We're just only given the coordinates of the pre-image and the image. We got to think about what is the transformation that's going from one to the other. So we're really going to be looking at the coordinates and I guess like putting our detective hats on and figuring out what is happening from one to the other. So let's notice anything that we can notice here. So number 1 is it does not give us a type of a transformation. We got to figure out, is it translation? Oh, sorry, it does say it. Describe the translation here. All right, so this is going to be moving it up, down, left, right. Let's look at the first 2 points here. Or sorry, the first points in triangle PQR and the other triangle of JOJ, which is 0, 3. So look at what are the difference between P and J. So first one is 4, 3. The second one is 0, 3. Let's go and highlight the next one. Q and M. Q is -2, +2. M is -6, +2. And then the last one, let's go blue. R, which is 0, 0. E, which is -4, 0. So what do we see it's happening with each one of the points of the first triangle to the second triangle? Okay, I'll give you a little bit of time to figure that out. But what happens here is each one of the X values, those are changing. Now, how are they changing? Right? They're getting bigger, smaller. Since this is affecting the first value, which is the X, that means we're translating this left or right. It would be going left if it gets smaller, right if the numbers become bigger. And as we can see here, each one of these numbers, 4, -2, and then 0, these all become smaller. So what this means is triangle PQR, we're going to move this to the left. So this PQR translates 4 left from the other triangle as we see that each one of those X values are decreasing. Okay, we're not going to work on B. We're just going to do all the A parts of this in the next page on activity 3. So let's get to section or problem 2 here. In this case, we have this triangle PQR, and we're going to describe the rotation here. So that's more familiar to this other triangle. And as you look at 2A, we have J, M, and E. So let's look at the first one. If you notice anything here, P is 1, 3, J, -1, +3. And if you don't have a highlighter, again, just circle these. Q, 6, 5. M is -5, 6. Okay, so there's some similarities and differences there. R and E, R is 8, 1. E is -1, 8. So what is happening here? Before I write anything else, I'm going to put X, Y. Now, it looks like if you look at one to the other, the X and the Y switch. As you can see for P, it starts out with 1, 3. The 3 is in front and the 1 is behind it. So we're going to switch X and Y. But as you can see, there is something that changes with the signs. It turns out that all the Y values here, the 3, the 5, and the 1, those all become the opposite. As you can see here, -3, -5, -1. So the Y values are opposite. So this, unless you commit it to memory, I would recommend looking at your rotation notes. Which one of the rotations that if you would have to switch the coordinates and make Y the opposite. In this case, we're going to take triangle PQR, rotates, and this describes a 90-degree counterclockwise rotation just by looking at the coordinates, right? We don't have a figure that we're looking at. That helps us there by looking at the rules. So this, I'm going to recommend, right? Tomorrow, most likely, we'll get to our test. Study these. Okay, we'll get to this on Talk the Talk fairly soon. And let's get to the last part on activity 3 on page 77. And then we'll get to Talk the Talk, which is number 3A. We take this triangle and we're going to perform a reflection here. So let's see what we notice. Angle P to angle J. So point P to point J, I should say. We have 12, 4 to being -12, +4. Let's go with yellow. Q to M. Q is 14, 1, whereas M is -14, 1. And then last, I'll go in purple. R is 29. E is -20, +9. So this is requiring our sense of analysis and being able to deduce, right, what is changing and what's similar. So what's happening here, X and Y, they still stay X and Y. Nothing switches, But in this case, it turns out that all the first positions, which are x, is the opposite. So we did this a while back, but try to remember this is a reflection, and this is a reflection about a specific axis. It's either the y-axis or the x-axis. For this one, we're going to say triangle PQR reflects across the y-axis. Remember, when we reflect about the y-axis, y stays the same. It's the other variable, x, that changes. And since x was the thing that changed, we know that it was reflecting about the y-axis. Okay. All right, so from there, we're going to skip B. We're going to skip number 4. You're welcome to attempt those, but we're going to move on to the last part, which is talk the talk, which are all the rules that we learned in Module 1, Topic 1. And this is going to be the paper that I'm going to recommend. I'll put a star here, that we use for our test. This has all the rules that we discovered since we started this topic. Okay, what this is having us do is it's having us figure out where do these rules apply when we either perform a translation. I'm going to draw a line here separating that from reflections, and then finally going to rotation. So what goes where? And we're also going to provide a description of what does the thing do. Okay, so let's start with translations. The translations are one of the it has 4 as the most of the 3 transformations. So first one we're going to do here is translating this. We'll go to the right. I'm going to circle this one here, and I'll write that in here. So this is x comma y plus c. What this does is it translates, this translates to the right c units. Okay, it's with the y, so that means that this is translating up. I apologize for that. Translating to the right, something different. Let's go to this one next. X comma y minus c. Since it's with the y, it's still vertical, but not up. This will move it down c units. Let's go to another one. We'll go to this one right here. X plus c comma y. Since it's with the x, this will change it left or right, and since it's positive, this will be right. So moving it right c units. And then finally, the last one that's adding or subtracting is that middle one there. This is x minus c comma y. And that's, since it's minus, this will mean move it to the left. So what I mean here is, yeah, it's not always going to be a c. Let's say this is x minus 4 comma y. You don't have to write this. This means move it 4 units to the left. Translate it 4 units to the left there. Okay. Anyways, moving on to the next one, which is reflections. And there's only 2 of them that we're going to focus here. That is, we'll go to this one first. And this is, we'll write it here, x comma negative y. What this means, you're going to reflect it about one of the axes. Since we're changing the x, this means reflect, I'll put R-E-F-L, reflect across the x-axis. Always change the other one that is the opposite. And the other one is, looks like, where is it at? Right here. Negative x comma y. Since we're changing the x, this means reflect about the other axis. This is reflecting from the y-axis. So if you reflect about the y-axis, just change the x variable. And the last ones that are more familiar for us, there's 3 of them. We'll go to this one right here. Let's say this one. All right, this is y comma negative x. So we're switching and making x the opposite. This describes a 90-degree clockwise rotation. So this way. Right, so if the test asks you to rotate it clockwise 90 degrees, you know to switch them, make x the opposite. Next one we'll go with is negative y comma x. So switching, but making y the opposite. That is this one right here. This is a 90-degree counterclockwise rotation. So going the other way. That's the rule. And the last one here is negative x comma negative y. This is where we make both of them the opposite, and this describes a 180-degree rotation. Doesn't matter where, clockwise or counterclockwise, that is all. Anyways, I'm going to ask that you move to the assignment, which is the next page. It should be page 79 and 80. All right, thank you for listening.